In this video, we're going to discuss Section 8.2, testing a claim about a population proportion. We'll be reviewing the p-value method and the critical value method. You need your guided examples notes for hypothesis testing packet as we go through this. We'll go through the first half of it in this video. Please pause the video and make sure that you have your guided notes. On the first page of your guided notes, you'll see a review of the p-value method and the critical value method. We went through these in the 8.1 PowerPoint, but we're going to go step by step and use these processes today to conduct actual hypothesis tests for proportions. The second page of your guided notes is a summary of many of the skills that we learned about hypothesis testing in our introductory lecture. There are two things on here that we haven't talked about and I want to point out to you. First is on the upper right hand corner, there's a table of common critical values. This is the table that we'll get our critical values from for our hypothesis testing. I want you to note though that the top here is confidence interval, confidence levels, and critical values, the three most common. But then after that, we have hypothesis testing for a right-tailed test. So if we have a right-tailed test with a particular significance level, we can find the associated critical value without making any calculations. Next, we have hypothesis testing for a left-tailed test. We have our significance values on the left and the critical values on the right. We also have a two-tailed test below with our significant values and our critical values. It's important that you pay attention to what section you're getting your numbers from. We move down to the lower left-hand side of this same page towards the bottom. We have our calculator steps. These are also in your calculator packet, but these are the steps that we're going to need in order to perform our hypothesis tests in this unit. Now we're going to jump right into an example for hypothesis testing of a proportion. We have 1,009 consumers were asked if they are comfortable having drones deliver their purchases. 54%, or 545 of them, responded with no. Using a 0.05 significance level, test the majority claim that more than 50% of consumers are not comfortable with drone deliveries. Now, for hypothesis testing for proportion, you need to make sure that you're meeting the requirement check. So here we have 1,009 consumers are randomly selected. There is a fixed number, 1,009 independent trials with two categories. So remember, we have to have success and failure. So the subject is comfortable with drone deliveries or not comfortable with drone deliveries. Those are the only two options. Then we must make sure that we're meeting the requirement of n times p is greater than or equal to 5. And n times q is also greater than or equal to 5. So here we have n equals 1,009, p is 0.5, and q is 0.5. So we can't just say, yes, they meet the requirements. We need to show this. So we get n times p is 1,009 times 0.5, or 504.5, definitely greater than 5. Then we get n times q is 1,009.5. Once again, 504.5. Also greater than or equal to 0.5. So we can get into our hypothesis testing. So looking at the problem, we have to test the majority claim that more than 50% of consumers are not comfortable with drone deliveries. So our claim is that P is more than or greater than 0.5. That claim does not include equality. So for our null hypothesis, we're going to write P equals 0.5 because it always has an equal sign. But our alternative is going to be the same as our claim. P is greater than 0.5. The significance level given to us in this problem is 0.05. So we'll write for part C, alpha equals 0.05. Now we need to make a labeled diagram and find the test statistic. And what I'm going to do is I'm going to show you how to find your test statistic using your calculator. And we can also look at a diagram on our calculator. If you go to page 2, where we have hypothesis testing calculator steps, we know that we're finding the hypothesis, test a hypothesis about a population proportion. So that is the second option here. We're going to go to stat tests and use option 5, our one prop Z test, follow the prompts. In the calculator, you can go ahead and press stat, go over to test, and then press option 5, which is our prop Z test. Our p-value is 0.5 in this problem, and x is given to us as 545, which is our 54%. The n value in this problem is 1009, because that's our sample, right? And where it says prop here, and you have some options, not equal to, less than, or greater than, you want to choose the one that is the same as what you see in your alternative hypothesis. So we see a greater than sign in our alternative hypothesis. So we're going to go ahead and calculate. Make sure that you have a greater than sign. And we can calculate or draw. Actually, let's go ahead and draw. So you should have a diagram now, which has a right tail test because we chose greater than. But on here, you should note that we have a Z value, 2.55, and we have a P value of 0.0054. This P is our P value. Let's write those down. So I've written my test statistic, Z is 2.55, and I've written my P value, and I'm going to fill them in on my diagram. So I have a right-tailed test, and I knew that because I have a greater than sign. And the shaded region is 0.0054. That's related to my p-value. Make sure when you write these down, you label them. And this borderline right here is 2.55. Now, I need to determine whether to reject or fail to reject the null hypothesis. First, we'll do this using the p-value method. So for the p-value method, we always take our p-value and we compare it to alpha. So our p-value, we always write it on the left, is 0.0054, and our alpha is 0.05. Now, I think 0.0054 is definitely lower. So we learned that if p is low, the null must go. So we're going to reject the null hypothesis. And I want to also show you a visual of this. So our 0.0054 is right here, but 0.05 is this larger region. So you can see your p-value fits in to the larger region of your alpha. So if your p-value fits inside that alpha region, then you reject. We also learned about a critical value method, so I want to show you how to use that. Go back to page 2. We know that we have a right-tailed test with a significance level of 0.05. So our critical value is 1.645. On our diagram, we can see that 1.645, that's the border here of where our alpha and our unshaded region is. You can see that 2.55 is more extreme. Since this is a right-tailed test, we're rejecting because this 2.55 is more extreme or greater than 1.645. So you could use either method, but these are both ways that are showing us that we're rejecting, because the fail to reject region is the unshaded region. Let's determine our conclusion sentence. So we can look at our diagram for wording conclusions, and we have here, does the original claim include the condition of equality? No, it didn't. It had a greater than sign. And then did we reject? We sure did. So we're going to use the wording of the sample data support the claim that and fill in our original claim. In conclusion, we can say the sample data support the claim that more than 50% of consumers are not comfortable with drone deliveries. Make sure that you have all of these components for your work, from the requirement check down to the conclusion statement in the format that we discussed in class. Let's look at the next example on page 4. Based on information from the National Cybersecurity Alliance, 93% of computer owners believe they have antivirus software installed on their computers. In a random sample of 400 scanned computers, it's found that 380 of them, or 95%, actually have the antivirus software programs. Use the sample data from the scanned computers to test the claim that 93% of computers have antivirus software. Our first step is to do a requirement check to make sure we can actually do this problem. So, the 400 computers are randomly selected. Check. There's a fixed number of independent trials, and there's 2 categories. You either have the software or you don't. And next, we have the requirement of NP is greater than or equal to 5, and NQ is greater than or equal to 5, and both are satisfied with N equals 400. You can see that when we find NP and we find NQ, both of the numbers we get, 372 and 28, are both greater than 5. So we're in the clear there. Now we can get on with our problem. So we need to find the claim. The claim is that 93% of computers have antivirus software. So that would mean P equals 0.93. Now we need to write our hypotheses. Our null hypothesis always has an equal sign. So we'll have P is equal to that same number, 0.93. Our alternative, well, it's either equal to or it's not equal to. So P is not equal to 0.93. We are not given an alpha for this problem, so we're going to assume we have alpha equals 0.05. Now let's take out our calculators. All right, so we're going to type in stat, go over to tests, and then hit number 5 because that's your one prop z test. Our proportion in this case is 0.93. We have x is 380 out of n is 400. Now, the symbol we used in this one was not equal to. Remember, using the same one that we had in our alternative hypothesis. And you can press calculate if you want, but I always like to go just straight to draw. And we have a two-tailed test here with p value of 0.1169 and z is 1.5677. When we go to draw our diagram, we need to remember that this p-value is split into 2 tails. So we really have 0.1169 divided by 2 in each tail. You can calculate that number or just leave it as divided by 2. And then this 1.5677 is on the left tail of our two-tail test. We need to determine now whether we're going to reject or fail to reject. So using the p-value method, we can say 0.1169 compared to 0.05. And we can see 0.1169 is greater. So if p is high, null will fly. So we will fail to reject the null hypothesis in this case. If we use the critical value method for a two-tailed test, we can see that at a 0.05 significance level, our critical values are plus or minus 1.96. On our diagram, I've added these critical values, and you can see the shaded region is 0.05 split into each tail straight in 2. So 0.05 divided by 2 is in each tail. And the fail to reject region goes from one shaded purple region to the other, the area in between. You can see that 1.5677 falls in the fail to reject region. Now we need to write our conclusion. For this our example, our original claim did include equality, and we failed to reject. So we can say there is not sufficient evidence to warrant the rejection of our claim. We can say there is not sufficient evidence to warrant the rejection of the claim that 93% of computers have antivirus software. Now I want you to try the examples on page 5 and 6 of your packet. And then you can check your answers. But if you're having trouble, you can go ahead and tune in to the next video in which I walk you through both of those examples.